This video will be covering the virtual limiting reactant lab. So the first thing you'll need to do is secure a copy of the lab sheet from the teacher. If you have not already gotten one from the teacher, it can be downloaded from Canvas. You're also going to make the necessary changes if it has not already been done on the lab sheet you've been given. You're going to want to make sure, number one, that you have an additional column called the appearance of the substance. Number two, you're going to add a row to record the mass of your filter paper. And then number three, you're going to black out any gray sections on the data table. So any section that has been grayed out on my data table, you're going to black it out. Please pay attention and make sure you are blacking out the correct sections on your data table. This is a picture of all the materials that will be used for this lab. So step one, you're going to weigh a clean, dry 150 milliliter beaker, and then you're going to zero your lab balance. You're going to then accurately weigh approximately 2.24 grams of iron filings into the 50 milliliter beaker. This mass that you see pictured on the table, you need to, in the lab balance, in this picture, you need to record the mass of this data in your table. So the mass that is displayed on the lab balance in this picture, record that to your data table. Procedure 3, you're going to weigh a clean, dry 100 milliliter beaker, and then you will zero the balance. You do not need to record this mass down. Then you're going to accurately weigh approximately 12.50 grams of the copper 2 sulfate to the beaker. You're going to record the mass that you see pictured here to your left. This is a picture of the iron and the copper 2 sulfate. You need to record their physical state, the color, and the texture of each of these reactants. Procedure 5. You're going to add 50 milliliters of distilled water to the 100 milliliter beaker. So here is my graduated cylinder. There's 50 milliliters of water in the graduated cylinder. Now the graduated cylinder is empty. I've added the water to my copper 2 sulfate that was in the beaker. Then procedure 6, heat the solution on the hot plate and stir until the crystals dissolve. We are using powder, so this shouldn't take more than a couple of minutes. Do not let the solution boil. You're then going to remove it from the heat using the beaker, tongs, or mitts. Remember that the glassware will be hot, so handle carefully. So there we go, using the stirring rod to help speed up the dissolving process. You can still see a few crystals in there. So we'll keep that up until it all dissolves. Then this is still procedure 6. This is what the copper 2 sulfate solution looks like once all the crystals have been dissolved. It is a darker blue solution. Now, these are our two reactants. We have iron and we have copper 2 sulfate dissolved in water or an aqueous solution. These are our two reactants before they are mixed together. Procedure 7 says slowly add the hot copper 2 sulfate solution to the 150 milliliter beaker containing the iron filings. Be sure the addition is slow to avoid excess frothing and possible loss of material. It will help to avoid frothing if a wooden applicator stick is placed in the beaker before adding the hot copper 2 sulfate solution. So here we're adding it. We don't have the wooden applicator stick, but we're adding it, the copper 2 sulfate, to our iron. Got it all in there. Then it says procedure 8, we're going to swirl the flask to ensure completeness of reaction, and then we'll let it cool for approximately 5 minutes to let the solid copper product settle to the bottom of the 150 milliliter beaker. So here we go, swirling it, swirling it. Hands need some lotion, but that's okay. And a manicure, but that's okay. Moving on. This is your reaction after 5 minutes. And I do want to make sure you understand that this image shows has the word iron in it. This is not iron that's in the bottom of the beaker. This is copper. All right. So even though you see the word iron, this is not what is in the beaker. You have the solid material is actually copper. Again, this is your reaction after 5 minutes. While you were waiting for the sample to go to completeness, you also should take the mass of a piece of filter paper. You're going to want to record this mass on your data table under where it says mass of filter paper. Then we're going to filter our mixture after the 5 minutes. So what happened is I took that filter paper that we took the mass of, I put it inside this Buchner funnel. I added a little bit of water to it in order to make sure that the filter paper is laying flat on the surface of the Buchner funnel. And then here's a video of the filtration process. So this is actually hooked up to a vacuum pump. I'm pouring my mixture into the Buchner funnel. And then I'm going to turn the pump on. And as you can see, it's pulling that water out faster. That was the vacuum pump. And the filtrant is in the flask. You can see the copper is being caught in the Buchner funnel by the filter paper. I'm going to wash the copper well with distilled water to remove the dissolved solution. Watch the video. You're adding water to that beaker. Try to get some more of that copper product out, as you can see in a moment. Copper, ashy hands. All right. Again, I'm going to turn the pump on and filter that out again. Get that water out. So whatever did not come out through the filtration process, I then used my scoopula and I scooped it out of the beaker and then I placed it onto the filter paper, what you see happening here on the right. As you can see, there's still some material that's left in the beaker, but I tried to get as much of it out as I possibly could. All right. So this is the image. I discard the filtrate, which was the liquid that was still in that Erlenmeyer flask. Then I took my filter paper and copper and I laid it on a piece of scratch paper because as you can see, some of the particles fell and I did not want to lose any more product. So I laid it all on the scrap paper and allowed it to dry. And this is what my product looks like after it was dried. You're going to want to record the appearance of the dry recovered copper 2 sulfate. You want to talk about the texture, what it looks like, the color of it in your description. Then I went and got the mass of the scrap paper, the filter paper, and the copper. Since some of the copper was on the filter paper, I mean, was on the scrap paper, I needed to get that total mass. So the number you see here, 4.52 grams, you need to record that somewhere to the side because we're going to eventually subtract the mass of this scrap paper so that we will have just the mass of the filter paper and the copper. Right. So the mass of the scrap paper was 2.21 grams. So you're going to subtract that number from 4.52 grams. Once you do that, you will have the mass of the filter paper and the scrap paper, and you need to record that number on your data table. That is the end of the lab. So now what you're going to do is you're going to complete the entire that data analysis. It is made up of 6 questions. For question 6, you have all the data needed to calculate percent yield. So disregard the statement that says this question can't be answered until next class. That is not correct for the virtual lab. You can do all 6 questions. Make sure you show all the required work and units, and don't forget your significant figures. That's the end. Bye bye.